and the length of cylinder, this lateral view you may say, R is its radius. What we do is we take wire, or let's say I take charge, not wire. I take charge Q and distribute, please write it down, it is being articulated in the class, so there's no literature, nothing of the type. Whatever is coming your way, write it down. A cylinder being taken, cylinder of certain radius R, and what we did was, we placed charge Q on the surface of cylinder. Got it? We place charge Q evenly distributed where? On the surface of cylinder. Yeah? All of you please camera on.
So is it a solid cylinder or a hollow?
First camera on. Doesn't matter. How does it matter? Solid cylinder or hollow?
Moment
I
of
said
inertia.
evenly distributed on the surface. Right? Okay? What is it? You'll get to know. Let me complete first. Whatever coming is train of thought. Write it down. Got it? Clear?
Yes, sir, clear.
Yeah, don't disturb the train of thought for now. I have taken a cylinder. What is charge which is being on cylinder distributed? Q. Length of the cylinder is L, R is the radius. Then what I was trying to do is, to the string I am trying to attach mass. And rotate. And then I am trying to find what will be angular acceleration of the cylinder. That's my question. What I'm trying to thinking about. Taken a cylinder, distributed charge Q on cylinder, made an arrangement of the kind, this one. We may assume that the string is one, there is a string as well. One cylinder string is one. And to one end of the string is connected this much. And then what we will do is let the system fend for itself. So the system fend for itself, it will start rotating, this will start moving down. It can rotate about its axis. There can be multiple questions asked on it, but I need to know what are you getting from my first task. Are you able to hint what I'm trying to deliver this question for is not rotational mechanics, but the topic that we are in. I want to see will you be able to relate to the topic which we are in or not. That's the reason I have taken this question.
Sir, could you repeat the final question? Like, what are we asking?
I told you that it is train of thoughts. There is no language. I'm still articulating. So whatever is coming to you, write it down. It's a cylinder of length L, radius R, on which charge Q is evenly distributed. There is a wire also which is wound on the cylinder, or string also which is wound on the cylinder. One end of the string is connected to cylinder, and the other end of the string is connected to mass. Cylinder can rotate about the axle which passes through its center. Axle and axle of cylinder are same. We can for now neglect moment of inertia of cylinder. It's very small. Not zero though, but small. We wish to calculate a few terms over here. I begin with what will be angular acceleration of the cylinder. You can take moment of inertia as I naught. I don't have any issue. Present your answer in terms of I naught. The simple ask what will be angular acceleration of the cylinder. How would you go about it? And through this question, I want to get from you a gauge on, if presented, will the student be able to relate to the topic that we are discussing or not? If you are able to, good. If you are not able to, I don't think students are in position to distinguish. So let me ask you, are you able to relate to the topic that we are? Question is find angular acceleration of the cylinder. How we will go about? Any idea? Anyone up here? What is angular acceleration of the cylinder? How will you go about a question which is on rotational mechanics asking for angular acceleration? Is that part with you or you need to brush it off? Much dust collected. You need to brush it off or you'll be able to solve just on angular acceleration.
We can do it.
Okay. Please figure it out. What we'll do? Help me walk through. Walk me through what we will do.
If this was like a simple question where we didn't have any charge, we would simply equate the torque is equal to I alpha. The torque in this case would be mg into r
Very good.
is equal
Good.
to I naught alpha. So alpha
Okay.
would be mgr by I naught. But
Okay.
here we have a catch. Here there is a charge on the cylinder, so we have to look for that. How to approach that?
Right. How will you calculate torque? Torque is it T into R? You said is equal to I into alpha. But what about T? T, how will you calculate?
So tension.
Yeah. You said T into R, you will equate it to I into alpha, and alpha will be T into R by I, right?
Yeah.
How will you calculate T? R is known to you, I is known to you, let's say. T is not known to you. How will you get T?
So we can do mg minus t is equal to ma, and
Right.
then we can get the acceleration of the
Correct.
mass
Correct. T
m.
is equal to R alpha, right?
Yeah, alpha r. Yeah.
Very good. Good. Absolutely correct. So, what is keeping you from that uses here?
So there's a charge on the cylinder which is going to impact the motion.
Okay, and in what ways? If you can throw some light on it. What's your name?
Ohm.
If you could throw some light on it.
1 minute, I'll think about it and let you know.
Sure, sure. I'll await. I'll await your revert. Anyone else? Any ideation press? Okay, please go ahead.
So the rotating charges will act like a current, creating a magnetic field. And if the mass has a charge, it will also gain another force due to the magnetic field.
Okay. So current charge will rotate, agreed. And as charge rotates, it will generate magnetic field, right?
Yes, sir.
Because that is tantamounting to flow of current in solenoid, right?
Yes, sir.
If radius is small enough, we can assume it to be infinite solenoid, right?
Yeah, we can.
Okay, good. You're on good scent. You're on good scent. Anyone else? Anyone else? So this can be incorporated. If you're ideating, then this can be factored in as a question. Good enough. Let us do that. Let us do that. Yes, anyone else? Please keep it pouring in. Come on. Yes, Tessa, Gauri, you're all not over here just to be mute spectators. Please partake, Ranveer, Adrika.
So I think Obuli is right.
Just a moment, Gauri, I want a response from you. Who has joined us, Gauri?
Yes, sir.
Yes, why were you mute? Am I supposed to poke you to get a response?
No, sorry, sir.
Trisha,
I'm not sure as to how it would affect.
No, not sure is no answer. Nobody is sure about anything, but we live. So you have to live by the time. Root yourself in what is taking place and answer. Got it?
Yes.
Advaita, Ranveer,
Sir, I agree with the magnetic field being generated, but I'm not sure how that's going to affect the tension. So I'm trying to find a relation between how the magnetic field could relate with the tension in the string.
okay. Ranveer, what is your call?
Yeah, sir, I tried first, like just writing the normal equations when charge wasn't there, but I realized that the charge will create a current and yeah, the magnetic field, but I'm still trying to relate to find a torque, like, or a acceleration from the like charges moving.
Okay. So others whom I have not called, what will they do is they know their state at this point in time, correct? What are they thinking? They will reflect it by writing that what was their first thought. What was their first thought? And have been received by one and all. There are 15 party. Got it? Got it, class?
Yes, sir.
You know? Got it, all of you?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
At this point in time, what was running in your mind? You are to think aloud. I'm not out there, so reflect it by writing it on a piece of paper and sharing it. I need to know your approach. Yes, sir. You were saying something. Back to you.
No, sir, I understood that it'll create a magnetic moment, but even I have the same doubt. How am I able to
Oh,
figure that out?
Vishnuvala, right? Correct me?
Yes. Yes, sir.
Yeah. Vishnuvala, tell me, you said that there is something related to charge, and when the charge is in motion, then it will tantamount to generation of electric current. What? The radius, if we can assume to be small, then this will act as solenoid, right?
Yes, sir.
Okay, so a charge when flows with an angular speed omega, let's say if it is rotating, then current we know is equal to charge divided by 2 pi by omega. That is the time taken for entire of the current to rotate once, which is what to get us in formula. If formulation is to be checked, we straight away do write that I is equal to what? I is equal to Q by T, and T can be written as, in terms of omega, you know what you can write. 1 by T is F, and F is equal to, we can write in terms of omega easily over here. What will it be? I, what do we write in general as? I is equal to Q into omega must be known to you. Is it?
Uh,
Sir,
Yeah.
so why can't we use L by M is equal to Q by 2M?
L by,
Sir, the angular momentum by magnetic moment is equal to charge by 2 into mass.
that is when conservation takes place. Man. How can you say over here that it is conserved?
So I don't understand. Why can't we use this?
dA by dt is equal to L by 2m is what we're talking about, right?
Yes, sir, I'm talking about that.
dA by dt area struct is constant, right?
Okay.
So how you know that it is moving with constant omega?
So because this cylinder is rotating, so
Rotating. It's rotating because you have let the system fend for itself. Doesn't mean that it rotate with constant angular speed. I didn't comment on angular speed. How can you say angular speed is zero? You have one
so,
torque on cylinder, right? You
so but
have
here you're
one
using
torque on
omega.
cylinder, right? One torque is there on cylinder T into R. T into R is one torque on cylinder which is trying to rotate it clockwise. If the torque is to get into this clockwise torque, then start rotating clockwise with an angular acceleration alpha, correct? Yes
Correct.
or no? Now, what qualms we had with this problem was, what about Q? What can Q do? There is Q, and Q is made to rotate. If Q is made to rotate, then we get current. How can we write current? At any moment in time, if omega is known to us, which is omega, let's say, then at that moment, this is not a constant current. At that moment, current can be written equal to charge divided by time taken for it to rotate for that omega, correct? Is equal to 2 pi by omega, correct? Getting it?
Yes, sir.
So that is the situation over here. I think Om is slightly confused. Yes, Om, please tell me the confusion.
So
Hmm.
I'm unable to understand why we cannot use a relationship.
Which relation?
L by capital M is equal to Q by 2 chota m.
That is for which case taken? What is that? Are you aware of what exactly is
Yes,
that?
sir. This we can
What
use
is
for the charge
that? What is
distribution and
that?
the mass.
Charge and mass relation under what circumstances, dear? You are
When
asking, suppose someone is asking you that calculate a sphere is rotating with angular speed omega, calculate what is mu, correct? Which are the
correct.
questions? Yes, so calculate what is the mu value of it when it is rotating with constant omega,
When it is
right?
rotating with constant omega. Okay, okay. So this is not constant omega, definitely.
Come on. If it's
Fine.
constant omega, then what's point asking you what will be alpha, dear?
Ha, ji, sorry, sir. Okay, now I understood. Yeah, makes sense.
That's when we-
Sir, I got like a few equations for the torque, and I wrote equations, but I'm not sure if they're right. Should I tell you what I got?
I'm just asking you about what you did say for torque T into R is okay, I got it. Then Vishnuwala did say something about current being a role play here. So if current is to play a role, then how we are to factor it? That was the question. If we
Sir,
are related that it is behaving a solenoid and solenoid, if we are to keep it simple, radius small, let's say, then it is to behave a solenoid of infinite length. Why I want to give radius small? Because then I'll be able to use directly B that it will generate is equal to mu naught and I, correct?
yes, sir, I did that and I got like a few equations.
Okay. So up to this point, I think nobody will have a doubt that yeah, radius small, it is generating what B field. It is generating a B field mu naught and I. Okay?
Yeah.
Okay. And Ni and Q can be related. Those are simple run of mill kind situation would be able to relate. So mu naught Ni is the B field. We have boiled down to this, right?
Yeah.
Next, mu naught Ni B field. And what do you say about I then?
Uh,
Will this B field be constant? Let me rephrase my ask. Will this B field be constant?
no, sir.
No. Why? Because there is alpha, there is omega, and current depends on omega. We know that, right?
Yeah.
So B field will not be constant. B field will change with time, correct?
Yes, sir.
Okay. All of you agreement? B field will change with time,
Yes,
Randir.
sir. Yes, sir.
Yes, sir.
Yeah, who is this? Sayom, tell me.
Yes, sir. I agree, sir. The B field will change the time.
Tell me. You have raised your hand. Raise one way. What's the question? You're in agreement or what?
Yeah,
So
sir.
because
So you're concurring, that's why you raised your hand, right?
Yes, sir. I also like I got like a few equations. So I wanted to tell the answer, but it's fine. Yes, sir.
No, no, it's okay. We are into SSO, as I told you, we are into articulating it. Any input will be an exorbitant welcome for you. Yes, please. Tell me what is it? Yes, and we.
Sir, yeah. So I found torque with IB because like if F is ILB, so torque should be IB, and I got like using the first thing I got D as mu naught N Q omega by 2 pi, and assuming N as 1, I got the torque.
Is one, why will you take n as one?
Like there's only one. Oh, okay, yeah, fine. I'll include n in my answer, and then I wrote the equation like torque should be opposing the tension, and like two equations from alpha.
Which torque? No, 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 just a moment, just a moment. Which torque are you talking about? Firstly, you got V, which is changing. So what will this V do?
Uh, it like there's because of the current around it, won't it induce a force?
Current will introduce force.
No,
Time
like
on the solenoid, how will it introduce force? I couldn't get that.
yeah. So even I'm not sure, but I tried to do something good like it.
Good try. Appreciate your try. Yeah. Vishnu,
Sir, since current is increasing and magnetic field is also will also be changing, can we say there'll be a self-induction on the coil, and then there'll be a opposite force?
self-inductance of the coil. Which coil self-inductance?
I mean, we have a solenoid, like it'll act like a solenoid. So there'll be a self-induction, and then there'll be like a
Yeah,
back voltage.
we can. We can. They got a self-induction. And by the way, we know also that there'll be an EMF induced, right?
Yeah, and then so it will start hindering alpha.
Just a moment. Just one at a moment at a time. I said EMF induced, which without giving a second thought, you said yes. What EMF did I speak about?
The non-conservative one. It will be in opposite direction
Why will that get induced over here? Yeah.
because I is changing.
So please take the statement with pinch of salt. You need to justify, right? Yes is no answer. Cannot be an affirmation with whatever I'm speaking. We feel changing, we have established. Then you will ideate on if B field is changing, then flux is changing. Right?
Yeah, right.
If B field is changing, then flux linking with the solenoid is changing. Agree?
Yes, sir.
B field is in the core. Correct. B field is in the core, and this B field is changing, right?
Yes, it is changing.
This current is changing, increasing. So B field, if current is increasing, first the direction of current into the board, then B field into the board, current anti-clockwise. The direction of B field due to current into the board, agreed?
Yeah, agreed.
Okay. Current is increasing, so B field into the board is increasing.
Yes, it is increasing.
If B field into the board is increasing, then B field linking with this area of solenoid is increasing,
Yes, it is increasing.
which zeroes down to flux linking with this solenoid increasing with time.
Yes,
All of
I
you
get.
on the page.
Yes, yes.
Yes, sir.
So flux linking with this solenoid is increasing with time. What did Faraday say?
There will be an opposing current to.
Those are the end result. That is not the statement here. Statement is wherever you are, you will get field induced. I told you in first class. If that field is provided channel, it will appear in the form of EMF. It can appear in the form of current. So the exact immediate is if we feel a flux is changing through area, wherever the area be air, conductor, non-conductor. Sometimes they will get you non-conductor and they will ask you on field. Field will get established. It may not manifest as current or EMF, but field will get established. That is axiomatic. Got it?
Got it, sir.
So field got established now, correct?
Field got established.
Which direction field will get established? That is obvious. They will try to reduce. So field will get established, right? This way, as seen by you clockwise. Can you say that? Yes or no?
The induce will, yeah, yeah.
For cylindrical variation of flux, we know how to write field. So if required, we can write field, right? E dot 2 pi r is equal to d phi by dt. We'll be able to get field, correct? In fact, we want field. So how will we get field? E into 2 pi r, E is the field. E is the field into 2 pi r is equal to what to us? Minus of d phi by dt, right? Yeah, class. You studied this, right?
Yeah, we have done.
So we get E. And if we get E, guess what? There is E. There is E everywhere. This E will generate torque, correct? Yes or no, class?
Yeah.
Getting it?
Yes,
So T into R, if I write clockwise, minus E into R, or force due to E to be precise, so I'll write Q. Minus Q into E into R, what that equal to? And not into alpha.
Sir.
Yeah.
Sir, I understood the magnetic field will be produced and the flux will be changing due to the increasing magnetic field.
Correct.
But can you explain the electric field part again?
Flux when changes, then there is an induced electric field generated.
Yeah, but can you explain the direction?
Which direction will it get generated? You tell me, recollect any reminiscence you do have. What does it try to do? What is the purpose of it, Purpose is to maintain flux.
Yeah.
So the flux is increasing, you try to decrease it. How can
Yeah.
it decrease it? It can decrease it by reverse current flow, correct?
Yeah, correct.
So, how will it be
Okay.
directed? Clockwise or
Okay, yeah.
anti-clockwise?
Okay, so got it. Okay,
Tell
yes,
me,
I got it. So it'll be in the upward direction because current is flowing downwards.
No.
Like in the anti-clockwise.
Anti-clockwise. Sense. We say sense. We don't say direction. Anti-clockwise sense, correct?
Okay, yes, sir.
And that will generate flux. Sorry,
Yes.
that will generate torque.
Yes, sir.
And that torque is what I'm writing as Q into E into R. Q into
Okay,
A
yes,
is
sir.
Q into R. And this will
Yes.
be equated to I into alpha.
Okay,
Right,
sir. Yes, sir.
so I think we are reaching somewhere on this. Try to figure it out then. First find what will be the value of induced electric field. Write down, class. I'll be asking you on this. Throw some light. First one is what will be the value of induced electric field? And second one is what is the value of alpha? We can factor in tension as well. At least two of them. What is the value of induced electric field? And what is the value of angular acceleration? These two ask. Yes, Om?
Oh no, I forgot to
Sir.
lower my hand. I was saying the same thing as well.
Come again?
I forgot to lower my hand. I was going to say the same thing as you. Electric field will form.
Okay, good enough. Good enough. Good enough.
Sir,
So,
can I give
yeah.
my inference? Fine.
Your inference. No, later, dear, later. See, we have limited time, right?
Okay, so can I say what I did?
Come again?
Sir, you told like we have to the electric field and tell, right? Can I tell what I got?
Yeah, you have to do it down or type and send it to me. Send across after the class, right?
Okay.
Okay. Now, few more questions quickly.
Sir.
Since we were dealing with the constant flux, what is the reason? So we have been harping on this concept. To solve this question. So the question is not new, but it highlights the concept which I have been carrying for quite some time, and that is what is the nature? Why do EMF get induced? Wants to keep its inertia same, status quo. So it wants to keep flux change. If you change flux, it will oppose that change. That is what the nature. And that nature will be highlighted in this question, which I'm going to get you quickly.
So for the previous question, can we assume n as number of turns per unit length?
Yes, please.
So can we assume n as number of turns per unit length for the previous question?
Those are to be left for you to think about what will you be doing, because what known to you I told you, Q is known to me, capital R is known to me, L is known to me, M is known to me, fine? And the other knowns mu naught, of course. Right, yeah? Yeah?
Yes, sir. Yes, sir.
Is it clear?
Yes, sir.
Okay, fair enough. So this is the situation that I am hinting on quickly. This is a mundane question, I would say. Not much new. L1, L2. So this was connected. This is a switch out here. 1, 2. This circuit was in connect for quite some time when you throw the switch from position 1 to position 2. Alright? The circuit was connected to switch 1 for quite some time. When we throw the switch from 1 to 2, we can make a distinction over here. Just a moment. Take this as well. And this as well. I'll come to the previous one later. R. And this is other one. I'll come to the other one which I marked later. You can keep that aside and solve this one first. So first the circuit was connected with L1 for quite some time, and then what we did, we threw the switch from position 1 to 2. You have to find current as function of time in the second circuit. Find current as function of time in the second circuit. Question well received?
Well received.
Is it okay? Question?
So it's connected to which switch first?
1. This is the connection for, you may say, infinite length of time, good length of time. And then you choose from where to where? 1 to 2. Correct? Okay. Quickly, please. Correct? 1 to 2.
So what do you have to find? Your voice broke for me.
It was connected to 1, then the switch is thrown from 1 to 2. So when the switch is thrown from 1 to 2, this circuit will change to this one, okay?
Yes, sir.
You have to find current as a function of time in this circuit. But in this circuit means this is the second phase of the circuit. First it was connected to L1 for good length of time. When it was connected to L1, L2 was not seen in picture. When it's connected to L2, L1 is not seen in picture. Am I clear?
Yes,
we
sir.
are clear.
Okay, good enough. Now, a concept. And then question back to topic that we are in. I got to know today I was dealing with few kids. I got to know that basic of electric field, I won't say, but certainly basic of, I'll not push one ball up to electric field, but we'll say dipole moment is not known to you. So I would like to ask you, what is dipole moment? What is dipole moment? We know the symbol, we know it's a vector quantity. We know that it is equal to Q into D, right? Are we aware of it? Yes, Anvi. What is the dipole moment?
Sir, it is the moment caused when like two like charges oppositely charged are placed like very close to each other.
Moment.
Or no, it's just like a quantity.
It's just a symbolic representation, right? That is what we can say. Not a physical quantity, a symbolic representation. Can you say that? As in magnetic moment I into A, so is electric moment Q into B. Are you all in concurrence with this ideation? Do you subscribe? Trust? Do you subscribe to this idea?
Indeed.
Okay. So let me ask you a question. In your room that you are seated, assuming it to be cubicle just for simplicity. I'll come to the organic shape later. And an arrangement is given to you. Q, 2Q, 3Q, 4Q, 5Q, 6Q, 7Q, something. And how much total now? And them all? 28. Is it? Is it? What class? 6, 20, 7, 8, 28. Right? Minus 28. It's a Q of side length A. Net charge is 0. What is dipole moment of this structure? Question is, what is dipole moment of this structure? What's count? What class? What happened? I've gone bonkers. What is it?
So could you show the question? I can't see.
You have solved this question? Have you, Ranveer?
No, I can't see the question, sir.
Oh. Nothing much. Just arrange charges. Net charge should be 0. You can take any arrangement. Correct?
Yes, sir.
Now what being asked in this is, what will be the dipole moment? Getting any air on this? Anyone? Quick dear. I have extended my time for your batch. I have taken time from the other batch. I have not informed them. They will be waiting. Because they have lost the other day as well. I cannot afford losing every other time owing to back-end team. So they will have to this time take care of it. Tell me, dear. What is it? Any clue, class? Quickly, wait. We don't have much time. Okay, no clue? Is it?
So do we take the charge and then add it vectorially, like the charge into distance with each charge and add it vectorially?
Take the charge and add it vectorially. We'll add charges
The charge
vectorially.
into distance, the dipole moment.
Charge into distance. What do you mean by
Yeah,
charge?
like the 5Q and the minus 28Q, then you take minus 5 from the minus 28, and then the dipole moment will be directed towards the 5Q. So
How can
5A.
that qualify to be called a dipole, dear? Dipole means equal and opposite charges.
Yes, so you take the minus 5Q from the minus 28, and then
That will be
5Q.
vector quantity, dear. That will be a vector quantity. It will be a vector quantity.
Yes, sir, vector only, and then you
So
try to
before you
add
have a
all
direction dictionary, how will you add those vectors? You know the angle
vec
between vectors. And sometimes can get you questions which have got a charge arrangement which may be unheard of. 100, 201, 237, 387, anything. So how many
yes.
combination we have to apply there? Will it yield? More so, we don't know the direction. So now I'll let you know what exactly is dipole moment all about, and then you'll get everything about it. When you say that I've got charge plus Q, I've got charge minus Q, be very careful about it, class. In 2018, rank 1 missed 5 marks. She was probably rank 1. She missed 5 marks. Why? Because he got confused with what we explain in chemistry direction of dipole moment. Right? We are known to that dipole moment in chemistry is inversion to dipole moment in physics direction wise. Correct?
Correct.
Yes, sir.
We are having good reason for it. We are not going when or going there. Not trying to berate anything. But certainly we have stronger reason why we take in this direction. You may be aware of it. I'm not to explain why is it. What I'm to explain over here is how we define P. What is P? This is D, right? What is coordinate of this? D by 2, comma 0. What is coordinate of this? Minus of D by 2, comma 0. Multiply Q with position vector. What is position vector? D by 2. That is the opposite, I think. 0, 0, comma. 0 depends on which axis I have taken. If I have taken x-axis, then that will suffice. If I have taken y-axis, then we take y-axis. So that's the customary in adherence to the precedent set. Yes, in adherence to the precedent set, I take 0 x-axis and d by 2 negative as y-axis. So d by 2 j cap for this one and minus of q d by 2 minus j cap for this one. Do check. Is it okay? Is it okay? Or
Yes,
is
sir.
it all multiplied with position vector? First one, secondly, the same. Charge multiplied with position vector. And adding them. What do we get to see? E into D, 0. Do we?
Sir, I'm not sure why did the first step.
Different first step. Charge multiplied with position vector.
Fine.
What is position vector for this? 0 I
D by 2
cap
J cap.
plus D by 2 J cap, right?
Yeah.
So charge multiplied with D by 2 J cap.
Yeah.
Second charge minus Q. What is the position vector for it? Minus
D
of D
by
by
2
2.
J cap. Minus this. Yeah.
Okay?
Correct. Yeah.
Written add them. They'll get added, right?
Yeah.
You didn't know. It's not your fault. You didn't know what is dipole moment. This is what is dipole moment. Dipole moment is not defined as Q into D. Dipole moment is defined as summation of product of charge with their respective position vectors. I repeat, summation of product of charge with their respective position vectors. Yeah? Now you may ask, what about, or I ask you, what if a person take some other reference? Will the answer change? There's the answer. I'm not taking that reference. I'm taking this reference now. I will get position vector for Q. I'll get position vector for minus Q from this reference, yes or no? Agree? Agree? Right?
Yes, sir.
I will take charge multiply position vector and again charge multiply position vector and can that get me a different answer from what you got here?
No, sir.
No, it will get you the same answer. Take any reference, you will get same answer. Why? Because actually what we are doing is we are finding difference between two vectors. And difference is independent of reference. Take any reference, distance between Bangalore and Delhi, when you calculate from that reference, it will come out to be same. Correct? Yes or no?
Yes, sir.
Yes, sir.
So take any reference, take it, take from it. This is R1. Assume it to be R1. Assume this to be R2. And then figure it out. Q into R1 minus Q into R2, right? What do we get? Q into R1 minus R2, right, class? Yes or no?
Yes, sir.
And from here, if you do R2 plus D, if D is taken this way, which is what we do, is equal to R1. So D is equal to how much? R1 minus R2, right, class?
Right, sir.
So what will it be? Q into D again. Agree?
Yes, sir.
So whenever a situation like this is given to you, the only caveat is you have to check net charge is 0 or not. Net charge 0, you are on good step. Take any reference, write down position vectors, then write down coordinates, write down their location of position vectors, add charge with the respective position vector, multiply charge with the respective position vector and add them all. Got it? Got it?
Yes,
What
sir.
do you do? Multiply charge with the respective position vector as taken from a position vector will be of course subject to reference taken. So multiply your position vector with the charges, all the charges that you do have, add them. Okay? And that is what is to be called moment. Clear? That was? Am I clear on this?
Yes.
Yes, sir.
I'll leave you with a question. And that is, and I go back to EMI. Let's do two sliders. I'm going to do this first, this horizontal element. This is plus first slider mass M, length L, second slider mass M, length L. Okay? Got it? Horizontally place first slider mass M, length L, second slider mass M, length L. B field is present to enter. It is then when you start moving this or give an impulse to it in this direction, to the right. Okay, class? You have got some R also to their merit. R here, R here. Only for the slider. Maybe C. Horizontally place slider, frictionless. Resistance over here, CD has got resistance R, AB has got resistance R. Mass and length R. Mass and length R. You give a push to it. V naught velocity. Starts moving it. To ask. Find current in this loop. Current in this loop as function of time. This loop as function of time. Okay? What
So
do you
what is
want?
R?
Current as function of time.
So what is R?
R is resistance of the sliders.
Oh, okay.
Resistance is only at in the slider. It's not on the horizontal rails. Got it?
So is the other slide fixed? Is
The
the
other
AB,
side,
is that AB rod fixed?
AB is the slider, CD also is the slider. CD is made to move to the right. AB at that point in time was at rest. Okay?
Okay.
What will happen to AB class? As CD moves, what will happen to AB? Think about it.
So it'll start moving.
So is CD's velocity constant?
Not constant velocity, Baba. I said that it is made to move with V naught. Initially pushed impetus.
Oh, okay.
And then it is system is let loose on its own. You give an impetus and system is then on its own, all by itself. then what will happen if you rest? Okay, current as a function of time. Current in the loop as a function of time. Any idea what can happen here? What will happen to speed of CD? What will happen to speed of AB? Any idea?
So the speed of CD will decrease and speed of AB will increase, and they will be equal at a point in time, so that the distance between them is constant and the flux passing through the area is not changing.
Okay, okay. And then thereafter what happened?
So then the change in flux will be zero. So then the net current flowing inside the circuit will be zero.
So what will happen? The rods will cease to move.
The rods will have constant velocity after a point, and they will be equal.
So they will be moving eventually with same speed, you mean to say, correct?
Yeah.
Can we conserve momentum here?
Wait, I'll have to think about that.
Can we conserve momentum here? And why you said speed of CD will decrease, the speed of AB will increase? Which force are you hinting on?
The force which will be active because to prevent the change in flux in the opposite side of C.
Okay. That will be the
And
direction.
this in the opposite direction of V naught.
You mean to say F is equal to I into L cross B.
Yeah, kind of.
And I will depend on VBL of both.
Yeah.
That means we'll have to take intermediate situation in which they are moving with velocity V1, V2, and accordingly generating V1, BL, and V2, BL potential, emotional, correct?
Yeah.
And then we will write equation for current, correct? At that point in time. From current, we will write equation for force, correct?
Yeah, good.
And accordingly, we'll be able to calculate what happens to current as function of, or what happens to velocity. Let me ask you what will happen to their speed as function of time. Write equation for speed as function of time. Right. Okay?
Okay.
Write equation for speed as function of time. Okay?
Okay.
Write equation for speed as function of time. Finally, what will happen? You'll get from the equation per se. Right, Vaibhav?
Yes, sir.
Finally, what will happen? You'll get from equation per se. Let the equation speak for itself. We want speed. Speed as function of time. That is what is being asked. Speed of B, speed of CD as function of time. You'll get to know over here also there being a time constant. What we have learned about yesterday, what time constant?
Yes, sir.
You'll get some lead on time constant here as well. It'll come out to an exponential equation of the same form what you have otherwise studied for Q, I. Look into it. Think about it. Okay?
Okay.
So this question is on all of us. Fine? Speed as function of time is what I'm zeroing down to. Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
One more thing. One just came. Just occurred to me one more. Let me club whatever we have studied. Let me club it. So this is a capacitor. C is the capacitance of the capacitor. Q is the charge on it. And what we do, we have kept a slider. This is D field. Or M length or Q charge U. What I do is, initially it was not connected, now I connect. Let us remove R. Make better. There is no R. Initially, this capacitor C charge Q is charged fully, was not connected to the system, then you connect it. With what speed will the rod start moving? With what speed will the rod start moving? When you connect, why should it move? Will it move? If it moves, with what speed it start moving? Everything is being asked.
Sir, is there a resistance R?
No, there is no resistance. Charge, you know. Capacitance, you know, was fully charged. Well, the center tenet or the cornerstone is to be decided. Where the crux of the issue lies in something which you'll be finding out here as an anecdotal evidence. You went into an experimentation, you connected it with a slider, frictionless slider, mass length known to you. You want to see what will be effect on slider. What will happen to slider? Will it get an impetus? What will happen? Come on, this you can do quickly. Nothing much. What happened, class? Impulse, FDT, ILBDT, IDT. Immediately there will be flow of charge through it, no R. So Q, LB, right? Is it?
Yes, sir.
And
Yes.
right. Take it there. Is it okay all? Impulse, FDT, that impulse will apply on
Yes, sir,
no
got it.
time. I into T is Q, Q flows in no time, there is no R. QLB, QLB is the impulse. Impulse we know is equal to change in momentum. Right? So start moving with what velocity? QLB by. Got it?
So
I
wait,
took
can you
time of
explain?
Yes, sir.
Can you explain after the second step, like ILBDT?
ILB dt. I into dt is charge,
Yes.
and there is no R here, correct?
Okay.
So I dt will be impulsive in nature, right?
Yes, sir.
That be not, that will also be factored in. That will be another question.
Okay.
Here it gets you Q, Q is making mark, and Q into L into V is MV then, right?
Yes, sir.
So start moving with that. Okay, class?
Yes, sir.
So I've taken time off and imparted in a way that period of exhibition with you. See to it that questions today are solved and shared with me by the end of the day. Okay?
Okay, sir.
Okay.
Yes, sir.
Guys, and a few of you, I would wish to extend further. I'll talk to you individually. Send me messages. Thank you.
Thank you, sir.
Thank you, sir.